And as we move on, I want to try and fill out this paper as much as I can with you guys. Also, I'm not planning to be here on Friday, so I know it's a pep rally day. We will finish the notes routine today. Usually we only spend 4 days for my trip, so just so that you can plan ahead. I'm going to leave you guys your reading guide to work on, so that's due instead of doing it over the weekend, so put my textbook in, or you can use the purple books, put the green books away, or you can work on some practice questions that I'll leave you, and then that's it. All right. Today is November 30th. Both of these questions are for me to practice AP exam. What's the AP number 1? Take a guess. What do you think, Luca? B is correct. So this question is kind of confusing because we know that the top three countries for coal reserves, but if you're looking at it, number 1 is not there. So you're like, wait a second, where's number 1? You're like expecting number 1, but it's just asking which one has the most. So it doesn't have to be number 1 or even number 2, but it happens to be China. So remember that it goes United States, Russia, and China. And then number 2 or 78, these are various stages in the formation of coal as heat pressure increase and moisture content decrease. These stages in order are, what do you think, Dana? D is correct. So even though your textbook and most books don't consider peat a type of coal, it's at least a precursor to coal. So if you ever see it, realize that it comes before lignite. So we're going to have peat, lignite, bituminous, and anthracite. They don't have stuff bituminous here. So if you had to pick, these are questions from the 1998 exam. When you saw them, when you took the practice exam, you're probably like, I have no idea what this is saying. But now that you have seen it, hopefully you would be able to get these right. So it's pretty. Okay, where did we leave off? You guys watched the video, right? Okay. So just to recap from yesterday, we talked about mining, environmental problems with mining. If you had to say one environmental problem with the mining process, what would you say? One problem. Any problem. So it could be subsurface or surface mining, either one. Destruction of habitat. So surface mining, we're removing all of the vegetation, the trees, and so we're removing habitats, so that can decrease biodiversity. What about health risks or accidents associated with subsurface mining? What are some of the health risks or concerns with accidents, Dina? Okay, that's with burning. So I'm just talking about the mining process, Eduardo. Yeah, so black lung disease is a health risk. Lung cancer is a health risk. Those are issues with subsurface mining. Something that you need to note that you'll see, acid mine drainage. I know that it was on the under the slide of the Surface Mine Control and Reclamation Act, but acid mine drainage, I showed you a picture of that. That should be something that you should be aware of, and that's when, if I go back to that slide, this is a picture of acid mine drainage, and you'll see this on the AP exam. There are questions that they like to talk about it. It's a major issue associated with mining for coal and other types of minerals. So this is an orange like liquid. It becomes very acidic, and it happens because the rainwater mixes with the open rock. So as you're opening and removing the earth, you have rock that is now exposed that contains iron and sulfur. And so now it's mixing with the rainwater, and now we have like this acidic water that feeds the mine. Okay. So impacts of actually burning for coal, carbon dioxide. You should underline sulfur and circle sulfur here, because you're going to hear all year long that one of the major issues with burning coal is the release of sulfur into the atmosphere, as well as mercury. Those are two pollutants that come from burning coal. And so the problem with sulfur and nitrogen is that they both cause acid rain or acid deposition. Mercury is a neurotoxin, and it ends up building up in our bodies, so it bioaccumulates, eventually biomagnifies to the top of the food chain or food web. And for pregnant women, for the fetus, It can cause nervous system problems and problems with their brain development. So mercury is also a major pollutant. Okay. So have you heard of clean coal before? People are like, oh, there's clean coal, and it sounds like it's like a really good thing. There's no such thing as like perfectly clean coal, but we do have technology in order to make burning coal actually less polluting. Before we can start talking about this technology, what do you think is the main drawback of this technology? What's the main issue? Before you even say anything, what is it? What do you think, Glenn? It's expensive. So the problem with these different types of air pollution control devices is that it's going to be very expensive. So the first one that we're going to look at is a scrubber. And we're going to revisit this in the air pollution chapter. But scrubbers are air pollution control devices. They're also known as desulfurization systems. So they're air pollution control devices known as desulfurization systems. And SOx stands for sulfur oxide. So that could refer to sulfur dioxide or sulfur trioxide. And PM stands for particulate matter. So when we use a scrubber, and this is a picture of a scrubber, not a very good picture, but this is a picture in the bottom left-hand corner of a scrubber. What it is we take water mixed with chemicals like limestone and other chemicals. We crush up limestone, and it's almost like a sprinkler system that sprays down into a smokestack. So here's a smokestack. Imagine that you're burning coal, all of this air pollution is coming out of the smokestack. This is considered a wet scrubber. So it sprays down water and chemicals into the smokestack, and limestone is going to react with sulfur. And so that's how it helps to make a precipitate. So sulfur actually precipitates out, and you end up with a solid material versus sulfur going out in the atmosphere as an air pollutant. So you come up with a precipitate. And currently, we take this sulfur and we throw it to landfills. But we really could reuse it for like floorboard or paperboard and other things. But currently, most of it ends up in landfills. We also help to reduce particulate matter. Particulate matter is any particles that go into the atmosphere. They're tiny little particles like dust, ash, or soot. And so it also helps to settle out particulate matter. So sulfur, it actually reduces sulfur by 98%. So it's actually very effective for sulfur, and it reduces the particulate matter by 99%. So again, the only issue with any of these is that they can be very expensive. And so a lot of coal companies or utilities companies, they would rather find alternative energy sources. So it may be cheaper for them to use like a solar panel than it would be for them to install a scrubber. The next one is called a fluidized bed combustor, or using fluidized bed combustion. This is another example of how we can reduce the amount of sulfur, and it also helps reduce nitrogen. So coal also reduces sulfur and nitrogen. You saw that in air pollutants. This is actually very common. And so if you look at the picture in the bottom right-hand corner, this is showing you an example of a fluidized bed combustor. And the way that this works, it's different than a scrubber. The way this works is you actually are burning both limestone and coal at the same time. So instead of just burning coal and kind of collecting the air pollution the way a scrubber does, at the end, you're going to reduce the pollution from the beginning. So we're burning coal and limestone, and because we're using limestone, that's going to help to remove or reduce the sulfur. So limestone in general removes the sulfur from the coal. And because we can actually burn it at lower temperatures, because we're burning two things versus one, it reduces the amount of nitrogen oxides that go into the atmosphere. So the lower temperature reduces the nitrogen oxides. The fact that we're burning limestone in addition to coal is going to reduce the sulfur. And so we're going to have just the same mechanism. We're changing water to steam through a turbine to produce electricity, but we're just going to have less air pollution as this coal is burned. And then the last one's called an electrostatic precipitator. It doesn't mention it in this chapter, but we will see it and also, like I said, revisit it in the air pollution chapter. And it mainly reduces particulate matter. So PM, again, particulate matter. Anytime you're burning stuff, you're going to have like soot and dust and ash that's going to go into the atmosphere. And so this is really cool the way that this works. Again, this goes into a smokestack, and what happens here is that you're going to have a negative charge right here, either a plate or some type of boundary that has a negative charge. You'll have positively charged plates on the sides of the smokestack, and as those tiny particles pass through, they're going to gain a negative charge, and then they're going to adhere to the positively charged plates, and then there's little collection areas. So once the burning stops, then we're able to collect all of that particulate matter. So these are just 3 ways in which we can make coal cleaner than it would normally be. Again, it's expensive. All right, we're done with coal. So moving on to oil and natural gas, we're kind of clump these two together. For oil and natural gas, basically, we didn't start using either one of these until the 1930s. Before the 1930s, we primarily used coal. And the reason why is because of the technology. We really couldn't have ways to explore for oil and gas. We changed over very quickly to oil and gas, and the reason why is because it's easy to transport, and it was basically, we were able to have the technology to find it. So oil and gas provide about 60% of the world's energy. And as we said before, oil is used mainly for transportation. So we're going to look how oil is separated into different compounds, where natural gas is mainly used for electricity and also for heating. But basically, we've made the switch over. Also, remember that oil and natural gas are cleaner than coal. So we made that shift because it's also cleaner. Coal is the dirtiest of all of the fossil fuels. It releases the most pollutants, where oil is the next dirtiest, or I guess you could say in the middle, and natural gas would be the cleanest of the 3. All right, so let's look at petroleum or oil. So this is really, the proper term is petroleum or crude oil. So petroleum or crude oil. And notice that I have the word hundreds of hydrocarbons underlined. So this is composed of hundreds of hydrocarbons. How do you think we get oil? So once we identify it, which we'll talk about in a second, how do we get the oil from the ground? We know that with coal that we need to mine for it. Yeah, Jackie? Yeah, so we drill, and then, yeah, we drill, we have wells, and then we basically make pressure underneath the ground in order to suck up the oil from the oil wells. separated by fractional distillation. So the process by which oil is refined into different products is called distillation. And I'm going to show you what we do with it. But you may not realize it, oil is in so many things that we have. We automatically think oil correlates only to gasoline. Can you think of other products that actually contain oil? Plastic. Plastic is huge. Plastic is made up of oil. So when we think of like, oh, running out of oil or oil prices, this is made out of oil. What else are some of the things that are made out of oil? Anything else you can think of? There's a lot of like topical creams and pharmaceuticals that are made of oil, tires, crayons, like our roofing. So much stuff is made of oil, so it's not just for gasoline. But if you look at the pie chart down here, it says 46% of our crude oil is made into gasoline. And then we have our other products here is at 11%. That's the stuff that I'm talking about. You have jet fuel, diesel oil, asphalt is made of crude oil, lubricants, and heavy fuel oil. So this is a fractionation tower. And this picture is in your textbook. And this is how oil is going to be separated into different compounds. So crude oil is going to be heated up. It's based on boiling point, so the highest boiling point is going to have the thickest, or it's going to kind of fall to the bottom of the fractionation tower, with the lowest boiling point being at the top of the fractionation tower. So this is what a real one looks like. And so, again, it's separated by boiling point. So the process is distillation, and it happens in a fractionation tower. So you can see our gasoline, lubricants down here, asphalt. So again, the process is distillation. Some of the things that, as we just said, that are made out of crude oil. So plastics, a lot of cosmetics. So oil will have like, will be part of like the lipsticks, anything that's like waxy tends to have oil in it. Crayons, different types of paint, candles, again, like waxy substances, tires, Vaseline, so this is petroleum jelly. Again, plastic, so your plastic wrap, and like roofing tiles. So these are just some of the things that are made of oil. You should be aware that plastic is made of oil. So that's a really big one. Plastic is made of oil. All right, natural gas. So natural gas, you should know, is comprised of a few hydrocarbons compared to oil, which was hundreds of hydrocarbons. And natural gas is comprised primarily of methane. So methane makes up the majority of our natural gas. We said that natural gas and oil are both formed in a similar way, so both by microorganisms. The difference, we said that natural gas was formed at higher temperatures. We tend to find them in the same places as well. So natural gas is mainly used for heating and cooking. So you can see if you have a natural gas stove. Maybe we talked about this yesterday. If you know if you have a natural gas stove, if it's found, like, if you have, like, first of all, flame. And then also you have, like, a tank, either in the front yard or the backyard of your house. Usually it's underground. They have to come fill it up with the natural gas. And it's also used to generate electricity. And we're seeing that more and more because it's a cleaner fuel than coal. Something kind of interesting, so we have now that's kind of becoming popular, natural gas cars. Has anyone ever seen or heard of a natural gas car? So they're pretty cool. A lot of them are considered fleet vehicles, like buses, taxis, things like that. But there's some that are on the market here in the United States. The biggest problem with natural gas, it's not about the pollutants, it's about getting natural gas from where we extract it to where it's going, because it's a gas, and it's difficult to take a gas, we can do it through pipelines, but it's difficult to take gas and send it over like bodies of water if we want to export or import. So it's difficult to export and import natural gas because it has to be liquefied, and it has to be changed into something known as LNG or liquefied natural gas. And that's what these cars run on. They run on liquefied natural gas. So this is a Honda Civic that runs on liquefied natural gas. And here are your top countries that use natural gas vehicles or NGVs. You don't need to know, but just in case you're wondering, we have Iran, Pakistan, and Argentina as your top 3 for using liquefied natural gas. And filling station. So this, if you actually purchase this car, which I'm going to show you the price in a second because I just thought it was interesting, but it's hard to find filling stations. So these are the filling stations I found in the area. There's literally like 4, and they range from Boca all the way down to Hollywood. So if you have this type of car, it would be less polluting. You can see the prices here. It's cheaper. It's, depending on oil prices, can be cheaper than filling up your car with gasoline. A lot of people who have invested in liquefied natural gas and buying these cars will actually have their own filling station. So you can actually have your own filling station at your house. And just the way if you use natural gas for your stove, they come and fill up your natural gas tank, and then you're able to fill up your car. This is from last year, so 2015, if you wanted a natural gas Honda Civic. It's just about $8,000 more than the base price of a regular Honda Civic. But I just thought it was kind of interesting. Would you ever be interested in buying a natural gas vehicle? Probably not. Would you rather buy an electric car, maybe like a Tesla?
Or
Yeah, it gets more miles per gallon. It's more efficient, but I don't see this becoming something big because you're really just changing from like one fossil fuel to another fossil fuel. I like the idea of the electric cars, but not using coal. So that's the only problem. If you're going to buy a Tesla or you're going to buy a nice, expensive electric car, which I think Teslas are coming down in price. Aren't they making one that's like in the 30s? Yeah, it's like actually cheaper now. Yeah, they're making like a cheaper version. But the problem is that you're still, if you're running the electricity, you're using, like, depending whatever FPL is using, so if they're using coal and natural gas, you're still using coal. Now, if it was done in a sustainable way, where the electricity was made from, like, renewable resources, or, like, they didn't use coal, then that would be something that I feel like would be better. Yeah. You read the newspaper? Okay, that's awesome.
FPL is raising their prices in case they expand their solar power and switch from coal to natural gas. And then also Elon Musk's original goal with creating Tesla was to create an electric car that everybody could use, so it could drive out all of the.
How cool would it be if you had like solar panels, or like we had like extended batteries where you kind of. Have you ever seen solar roads? Solar roads are super cool, where they're like these roads, and we'll talk about this with our renewable energy, and they haven't come out yet. It's something that's like still in the early phases. But they're roads, because think about roads. They're just sitting there all day collecting sunlight, and so they actually have solar panels within the road. They have like a top, which is they're working on. The problem is they're working on like a top to make it so it's not slippery. Think about when it's raining or if it's snowing, that has traction on it, and it would just absorb the solar energy, and like there would have to be a whole network of electrical like wires and stuff going to buildings, but it could help to power like buildings or even possibly cars someday. So it's a really cool thing. There's a lot of money's been invested to it, but it's just taking a really long time because think there's so many possibilities. What were you gonna say, Dave?
Cars and Teslas that superchargers that don't like use like coal and still also like a capsule.
Do they have those
Yeah,
conveniently around?
get a they go in your house and express.
Cool. So you have to get panels then.
Well, I think you have to try and get this.
There's already one. But yeah, so maybe expand it, maybe like put up another, another reactor. But yeah, there's one in Miami, Turkey Point. There's one in Hutchinson Island. There's one near Gainesville. There's two of them. I cannot wait for our next chapter. Like, the next chapter is like literally my favorite chapter of the year. No, it's about nuclear power plants. And I like it because there's so many misconceptions and there's so many things. Yeah, no, that's my first picture on the slide is Homer Simpson. Yeah, for nuclear power plants, what? You're recording. I know. For nuclear power plants, the worst part is going to be, and Luca and I were talking about this, is the waste. So what to do with the waste? We're going to get into it. I'm so excited. And that was the most important thing for your quiz on Monday. So I really hope that you guys wrote it down. It's basically the majority of your quiz. All right, so how is oil and natural gas, how are they discovered? So that's the next question. So this is actually, it takes a lot of people. You have to be pretty smart. Geophysicists, engineers, these are the people who are searching for oil and natural gas. And it's not easy. It's not an easy process. They try to come up with nothing and spend a lot of money looking for it. So basically, we have geologists and geophysicists, and they study rocks. They look for rocks on the surface of the earth. They also look for places where they think they would have structural traps or salt domes. And so they study the landscape. They make these maps about where they think that there could possibly be oil. And once they figure out an area by studying the rocks on the surface, then they are going to have people use, it's called seismicity. So enhanced seismicity, where they basically, another picture of this, but they, so this is basically what they do is they send seismic waves, just like if you think about an earthquake, seismic waves from an area or from a specific place down through the ground, and they wait for them to bounce back, and they have these geophones on the surface. And once they have these geophones in place, they are going to record data that engineers are going to look at, and from there they're going to determine if it's if they should do a test drill. Yeah. Yes. Basically what it is, but it's a lot more in depth. There's a lot more to it. So once they get these sound waves that are bounced back to these geophones, then they're going to decide if they're going to test drill. Then they're going to test drill and see if there's anything there. Many times, actually half the time, that they think that there's something down here because they're still kind of guessing. We really don't have a good way of getting down there and knowing. Half the time, there's nothing there. So we've wasted a lot of money and a lot of energy getting people together, going out there. But for our oil and natural gas, so it used to be that we thought that we only had a certain number of years left, but that is like not the case anymore. I don't know if anyone saw, but a couple of days ago, or about maybe a week and a half ago, they found huge amounts of oil in Texas. And it used to be that I would teach this class 10 years ago and tell students that for oil, we only have 50 years left. And for natural gas, we only have 75 to 100 years left. And literally that's what the AP exam wanted you to know. But they can't even ask that question anymore because new reserves are being found all the time. And not only are they being found, but new ways of extracting oil and natural gas are being used. So that leads us to fracking. Have you heard of fracking before? So this is actually started in the 1970s. It's not brand new. But this is making it possible to get more oil, and we're using, and I'll explain how it works, but getting more oil from horizontal drilling. We always used to be able to drill only vertically. That only allows you to get the oil from one area. Now we're able to horizontally drill. And so it says up here, basically it's hydraulic fracturing. There's not even that much in your textbook about it because at the time when your textbooks were published, it wasn't as big of a deal. But it basically, we're going to take millions of gallons of water. So this is like to start off with environmental problems, why environmentalists don't like this. We're starting off with millions of gallons of water. So a lot of water is being used. That water is being mixed with sand and a whole bunch of chemicals, different acids. And it's being pushed down into these wells at an extremely high pressure. And the whole idea, it has to be so pressurized that it's causing the rock, so this is going to be oil shale, like rock that contains an oil-like substance, and it's going to make it fracture or fissure. So we're making like cracks in underneath the ground. And it can be just as deep as 10,000 feet. And so what the sand particles are doing is kind of holding open these little fractures and allowing for the oil and the natural gas to get into this horizontal well, and we're able to take it up and remove it that way. So like I said, it only used to be that we would drill straight down. So the environmental concerns with the amount of water that we're using, the chemicals that are being put down there, you're like, well, who cares about the chemicals? What do you think could happen to some of these chemicals depending on how deep it is? Yeah, we're seeing like, we can see it in our aquifers, and the aquifers is the water that we end up drinking. And if anyone has seen Gasland, has anyone seen Gasland? In that, I think they show a guy who turns his water on, and he lights it on fire. And the reason why is because some of that methane, from the methane, is being drawn up, and it's going into the water, and then it's coming out of the faucets, and then people are drinking water that's contaminated with chemicals and methane. So the main concern for environmentalists is what's happening to the water, the amount of water we're using, and what is actually in the water and how it's going to impact us. Yeah, it can cause mini earthquakes. There are also complaints if it actually has like a little bit of noise pollution associated with it. A lot of these companies, they buy or they pay landowners to do this on their land. Well, maybe. Yeah, I don't know. Yeah, so these are some of the issues associated with it. Okay. And I have a video for you, but I'll show you later. Alright. Oil and natural gas reserves. So, quickly, just to go through, we'll do one more slide after this. Reserves of oil. Over half of the oil is found in the Middle East. So over half is found in the Middle East. You can see the Persian Gulf here. 50% of our oil reserves. Africa, Nigeria has a significant amount of oil. Canada has a significant amount of oil. We do too, but Canada's up there. So these are the areas that have oil. And these are reserves of oil, meaning that we've identified them and they're extractable. Now, the top 3 countries, one of them happens to be in the Middle East, but if you had to do it by country, they're not all of each country in the Middle East. So does anyone want to take a stab at the number 1? And if you have your little paper out or around. Canada's up there. Canada's up there. stop